Al, this is Jeff here for CS161B. This is the second video in module 7/8, Structs. So hopefully you have watched the first video that I did on this subject where I demonstrated the use of structs using GPS coordinates. And we went through, this is how you create a struct. This is how you assign values to items within the struct. This is how you use it within a function. This is how you have a function return a struct. Um, and so we covered in the book, I'm sorry, I don't have the book open. Let's open that real quick. We covered in chapter 13, basically sections 13.1 and 13.2. And what I want to do today is I want to build another example where we use structs and arrays, which covers the rest of 13, but it really covers the stuff that I want to cover also in chapter 14. And chapter 14 is just more examples and some more sophisticated examples. And I think my program kind of illustrates what we cover in chapter 14. Before I do that, there's a couple other things in the textbook that I want to mention that I wasn't necessarily going to demo, right? So last week, I showed that you could pass a struct to a function passing it by value. You can also pass by reference. Okay, now it's interesting because you can ask, well, why can I pass a struct by value and reference, but I can't pass an array by value or reference? And the answer is it's kind of unintentional feature is what's happened. When structs were first conceived, the intent was that they'd only be passed by reference, much like arrays. But there was some, I believe that there was some errors in how they were implemented, and you were able to pass them by values, and it's kind of stuck. And so in the example that I used last week, I was passing that GPS cord by value, and it worked just fine, right? So this has made it its way into systems over time. It's not nearly as much of an issue as it used to be. Programs have a lot more access to memory than they used to. Okay. Um, you can, if you want, put an array inside a struct and pass your array by value, which is a way to bypass the rule that you can't pass arrays by values. Um, there's really no reason to do this. The only possible reason you might do this is if you have very, very simple arrays or C strings and you're wanting to, just keep things simple. Um, this just falls into the camp of this is how it is, this is how it's been written, and it's not consistent, and the soapbox zealots on Stack Overflow have to get over it, right? It is what it is, right? But it's just an interesting point I wanted to bring up here. So you can pass your structs by reference or by value, whatever works best for you. In 14.3, the textbook introduces the concept of using .h files. Okay, we've been using .h files already, right? Some of these files up here sometimes are called .h, sometimes they're in angled brackets. But the idea behind, in this example, let's walk through this. I have in my main.cpp, I've done an include of store item.h. And inside store item.h, I have my definition of what the structs that I'm using, and the templates or how the functions are implemented. In very, very complicated programs, actually, I'd say even in moderately complicated programs, you're going to start doing this. You're going to take groups of things that belong together and you're going to put them in separate CPP files and or separate .h files. And this section kind of describes kind of how to do that. For the purpose of this class, don't do it unless it's explicitly asked for, because it's just another place where things could go wrong. I've gotten submissions from students where they submit the files and they forget one.h file, and I can't run and grade their program. And it's the final deadline of the term, and they forgot to do it, and they've gone off grid, and it's like a bad outcome, right? That has happened. So stick to the single main.cpp unless I specifically am saying otherwise that we want to do it to demonstrate the learning. Okay, and then the last kind of topical thing before we get into the code here is, what about putting a struct inside a struct? The answer here is yes, you can do that. So for example, if I took the program that we wrote last week and I said I want to make this more advanced, and instead of capturing just GPS locations, I wanted to create a database of points of interest. And we'll stick with the points of interest in cities around the world. I can have a struct, which is the name of the city that it's in, the time zone that it's in, the name of the attraction, its address, and then I could have the GPS struct as an item inside that struct if I want. So you definitely can do that. Okay, so just some, I call them a little bit kind of off to the side topics here. All right, so what we're going to do today in this video is we're going to build up a simple database. And so we're going to use an array of structs here. Okay, and I'm going to use Lego sets as my example here. Yeah, I'm a collector, a long-time collector, and I made a list of some of my favorite sets here. Okay, so let me show you what that data looks like. So here's the data we're going to use. You can see that it's in what's called comma separated value format, or CSV format. This is a popular format used primarily when you're putting things in and out of spreadsheets. Okay, and so each field is separated by a comma. So we're going to write some code to pull the 4 different fields here. You can see you got a product ID, you got the name of the set, and you got 2 numbers here. The first number is the number of pieces in that set, and the second number is the year that it was released. Okay, and so you've probably used CSV files before. We need to be able to read in the CSV file, so we're going to do that first. Last week, or 2 weeks ago, we talked about input streams, and we did some basic stuff. So we're going to do things a little bit more complicated here. One thing about CSV files, if any of your data contains a comma itself, like for example, your name might have a comma in it, the code we're going to write is not going to work. And dealing with commas inside fields, inside CSV files, is a whole nother level of complexity that we're not going to tackle here. And so if you decide to change your, like if you change this and say, oh, I want to do a mailing address database, and you have comma between the street and the suite number or something like that, this code is going to have some problems here. Okay, so doing the things. So let's start to work on this here, and I have much of the code written, but like usual, we'll probably flounder in a couple places here. So let's first let's use a struct to manage each Lego set in the database. So we're going to define our struct, and we're going to say, like I said, we have 3 fields. We have a product ID. We have a name, and I'm just going to use the string data structure here instead of the char arrays. Couple reasons, subtle reasons why I chose to do that may or may not come up as we walk through this. The number of pieces in the year released. We define our struct. Okay, while I'm up here, I'm going to create a simple print function to display the like if I give a set as a struct into this function, I just want to display the contents. So we're going to print the set name first, and then on the next line we'll indent, and we will print the product ID, And then on the next line, we will say contains num pieces and released in released. You're released. Okay, so we've defined our structure and we've written our display set because we're going to want to kind of be able to print things out as we do things. And so we should be good there. All right. Inside our main function, we are going to first want to read, we're going to want to read in this data and place it into an array that has array of the struct, array of the Lego set struct. Okay, and so we're going to create a function called int read data, and it's going to have an input stream, which we have to pass by reference, and we have our database, which I'm going to call inside my function LegoDB. We also need the function to open the file, and we did this last time as well. We're going to pass it the input stream and the file name. If in file fails, we return false. Else we return true. Okay, so kind of bouncing around a little bit here. So I have my open file ready to run. We used this function previously. Opens a file and returns a Boolean flag indicating the open was successful or not. Okay, so inside main, first thing we're going to do is we're going to declare our array. And we'll do that first by setting a limit on the number of sets. Remember, with arrays, we have to declare the size of the array. And 10,000 is a mighty big list. There's some collectors out there that have more than that. If you start doing databases of parts, it's way more than that, right? But we'll use 10,000s for now. I only have 14 in my database, so we're plenty good here. And then I initialize my array, which is called LegoDB, and it's an array of Lego sets, right? And my Lego set is my struct, and my current count in my array is 0. Now we will create my file name and our input stream. Let's make sure I have, so I do have fstream up here already. Okay. So I create my IF stream. Oops. No, what did I do? One sec. I lost some stuff. Give me one sec. Okay, I don't know what I did there. I reconstructed everything I've typed so far really quickly here. I hit some magic delete thing that I couldn't undo. All right, so you can tell that this VI editor is not my primary editor. I use an editor called Emacs, which has a much higher learning curve, but is way more powerful. And I can make VI VIM work, but you can see I kind of stumble from time to time. Okay, so there's my character file name, my in stream, my IF stream that I've declared. Now we're gonna call open file, and if it returns false, then I can print out my error message. And then I can exit. Otherwise, I'm going to call read data, and I'm going to pass in my in-file stream and my array. And in-file is going to return the number of sets that were found. And so we can confirm by printing this like that. And I also need to close my file. Okay, so now we're at a point here where I think we can compile. And when I run, we find 0 sets because read data doesn't do anything, right? You can see it just returns 0. Okay. This is, again, you see me do this all the time. I wrote, what is that, 60 plus lines of code there. And I hadn't tested a single line of code. Some of this we had written before, but making sure that your function templates are the same and your variables are declared and things like that. It's good to do things in kind of in sequence here. So now what we can do is we can work on read data. And read data arguably is the most complicated part of the function here, of the program here, because we have to do all this text processing. Okay, so let's see, read. So I'm going to say process the CSV file, each set into its own array element. Return total number of sets found. Limited error checking. Okay. The good thing about databases is that if your initial data is good and your software to add and remove things from your database are also good, when you read the data in, you don't have to often deal with all sorts of wacky errors compared to if you're just typing stuff in, right? So you kind of have some more control there. Okay, so what we're going to do here is we're going to use getLine in this case. So we're going to say in file getLine, and we're going to read in the entire line at once. Now we could try using the comma as a delimiter, but my preference here is instead to read the whole line in and then pull fields one at a time off of it. So we're going to declare our line to be long enough to capture our sets. Okay, and so we're going to do the get line, and then we're going to say while we are not at the end of file, we process the current line, increment the count, read the next line. And then turn the count. And we need to declare the count. All right. Okay, so there's our flow of what we're trying to do here. And so, am I forgetting anything? I think that's it. Oh, we need to process the current line, add it to the array. That's what we have to do. Okay, so let's think about Let's think about this in steps. So we're going to process the current line. We've our variable line. I'm going to just make a copy of it. And to use this is my string, and this is the one difference here that I wanted to call out. GetLine requires that you use an array of chars here. This can't be a string here. But I want to use some string functions. So I convert from C string to string so I can use substring primarily. And you'll see why here in a second. Okay. Now what we want to do is we're going to do this multiple times. We're going to process the line by grabbing the data before the first comma, placing it in the right variable, then removing that from the line so I can rinse repeat. Okay, so if that makes sense, let me bring up the CSV file down here. So in other words, I read this whole line in, right? And so if I use the substring command and the find command, I can find the first comma and then grab all of this using the substring. Actually, I grab that using the substring because I know where the comma is. Put that in the product ID variable, and then remove that because I know where that location is. Then I'm left with this, and I can repeat the process with the name, and then I'll be left with that. Repeat the process with the piece count, and so on. Okay, so it works quite well. You could do this in a loop as well if you had like hundreds of these. In this case, we're just going to do this manually. Okay, so we are going to find the location. We're going to use the find command to find the location of the first comma. So we need to declare a delimiter variable. And then we are going to, we can create some temporary variables here, or we can just add it to the array right now. I think we'll just add it to the array right now. So the array's name here is LegoDB. Lego DB of counts dot product ID is equal to string to integer, because remember this line 2 is a big string, substring from 0 to the position, to the value of the position of the comma, which means it's going to go up to but not including the comma. Then we're going to use replace, and we're going to go from position 0 to delim plus 1, which is the first character after the comma, and we're going to replace that with double quotes. Now, when you write this kind of stuff, I recognize that sometimes you're going to say, oh, do I have to add one to delim here or subtract one? Do I have to add one? Do I start, and you'll have to try it, right? Sometimes you just have to try it. Okay, and so why is this delim plus 1? Because I'm not indicating the length here in this case. I'm indicating the positions. Okay, so, and I think that's delim not delim minus 1, but we'll see when we run this. Okay, we'll see. Okay, so now we've successfully removed the product ID and the first comma from our string. So now we do it again. And now we have the, we got to do it different because we're doing a string. We're going to say name is equal to, nope, that's right, sorry. Lego DB count dot name is equal to line to substring 0 delim plus 1. No, sorry, I'm mixing my delim. And then we copy that line. So we do the exact same thing. I don't have to convert to integer, I just copy it over. All right, now I'm going to take these 3 lines and I'm going to paste them here. And that was weird. And this will be the num pieces. And now when we get here, all we have left is the year released. That's all we have left because we've gotten rid of everything up to now. Okay. It's a lot of code without testing it, but it is a lot of the same code. And I think if I made a mistake, it's maybe I needed delim plus 1 here, but we're going to see here. Okay. Increment the count and read the next line. I feel like we don't need extraneous comments here. So count plus plus. And then to read the next line, we're just going to go back up here and we're going to get that line. And put that there. And let's add our check. If we are not at the end of the file here, failure before end of file. Otherwise, we're going to return the count. All right, let's see. Let's roll the dice and see. Forgot to declare line 2, it looks like. All right, that's pretty good. All right, let's see what happens. Okay, it says it found 14 Lego sets. Okay, that's good, right? So at least we know that part worked. Now, let's test and see what we found here. So we're going to use the display set. And inside main, we'll just do display set 12 and display set 4. Oh, I need to pass in the array. So I need to pass in. So display set, if we go look at display set, no, it does. The display set only takes the struct. So this has to be, instead of this, it's got to be like that. And so I printed out set 12 and set 4. We can check to see if those are right. I'm pretty sure those are right. Okay, but there's our display in a formatted way, and it looks like our array has been filled. Okay, so now that we've read from our CSV file and we've brought the data into our struct array, now we can do whatever we want with it. And we could spend all day writing some code here if we want. But I think we're just going to create a menu here. And I know that I know that in many of our recent programs, we're encouraging you to create these functions with your menus and read the inputs and everything. But for the purpose of this demo, we're just going to do it all inside main like this, just to ease the time here and keep things focused. So let's see, list all the sets. That seems like something we'd want to do. How about see if we can find a set by product ID? Now let's just implement these two, and we'll see if we feel like that gives us enough. All right, so I've set an option value to 1, not because I want to run 1 first, but because I want to get into this while loop successfully. Then we're immediately going to read the option value anyway. So that first, this 1 could be 99, it could be -1. In fact, I think I like using nonsense numbers to make it clear that that number is not a real option, right? So now we'll say, and we'll just do some if statements here. If option 0 will break out of the loop, else if option is 1, we want to display all the sets. So that's pretty easy to do. We're just going to say for int I equals 0, I less than count, I plus plus, display set Lego DB with index I, just like I was doing with 13 or 12 or whatever I did manually. Okay, that's it to display the sets. That's pretty straightforward. Else if option equals 2, then what we want to do is we're going to create a new function called find set, where we're just going to pass the array of structs and its current count. And in that set, that's where the user will enter their product ID. We could separate that. Like we could have a function that says enter the ID with so much error checking, and then find the set with that ID. I'm going to simplify things and put that all inside find set. All right. So now the find set is a Lego DB an account. It doesn't return anything. And we can grab Lego set. All right, we wrote a lot of code again. Let's see. All right, we found our set. We got our menu here. I can go ahead and I can try. Okay, that doesn't work. I can quit works. Let's try option 2. It says nothing yet because I haven't implemented that. And option 1 prints my list. And that looks pretty good. All right, so now let's get our find set working here. All right, this is actually not that. I don't think find set is that complicated here. I just gotta find the find set. Here it is. All right. Okay, we need to get a product ID from the user, and we're going to create a found flag. This function, by the way, it could return true or false, right? If you wanted to. Since we're just printing the set inside the function, we don't need to do that. and that's why I declared it void. All right, so we're going to say enter the product ID. No error checking right now. Okay, what we will do is we will determine if we'll print the set if we find it, and we'll print a message if we don't find it, but we're not going to do any error checking on the ID itself, being numeric, positive, whatever. There is improvement that you can make here. And we're going to do this by simply going through the loop, and we're going to say if Lego DB of I dot product ID is equal to product ID, then we can run display set on Lego database of I. We can set found equal true. We could break out of the loop. We don't have to break out of the loop. We can finish running through the loop if we wanted to. And then here we can say if not found. If not found, it's not in the database. You need to go by the set, right? So, okay. So there's our find set, right? So we've passed in the array of structs and its size of the array. And we're simply doing the comparison on the product ID. We could change this, right? You can imagine. Actually, maybe we'll do this. I think we got a little bit of time. We're going to add one more function. But let's make sure this guy works. All right, let's do 10 to 12. Find a set 10 to 12. Prints the shuttle in 2,503 pieces released in 2010. Find the set by 233 is not in the database. Okay, more testing we can do. Like I always say, test for the first element in the list, test for the last element in the array. That makes sure all of your boundary cases are working, right? You want to check on empty arrays and things like that too, which we could do by zeroing out the CSV file and trying that, right? We won't do that here. All right, let's add one more. Let's add one more function. Display all sets with minimum piece count. Okay, we're going to kind of do the same thing here. All right. This is actually, the function is not going to be much different here. But we'll have it return a value as well. What we'll do is we'll have it, what we'll do is we'll have, no, that doesn't work because I don't enter my number of pieces until, I'd have to enter my number of pieces earlier. So never mind. Okay. I was going to say we can print it inside here. We'll just do it inside here. Okay, so step one, right? And minimum number of pieces. Oh, look what I did. I can't have count and count. What do we want to call this thing? Sets with min pieces. All right, kind of clunky name. I less than count, I plus plus. I'm going to say if, oh, we got our pieces. So we're going to say if Lego DB num pieces is greater than or equal to pieces, then we're going to increment our sets with minimum pieces, and we are going to display the set and then we can say found sets with min pieces. If I was writing this code for the purpose of not this class, I would sets with min pieces would be some variable name like x1 or x or something. As long as you're commenting it, it's perfectly okay. But I think you figured out if you watch my videos, I try to be kind of verbose with the code. Because some of you will find and use this code without watching the video, right? Found with at least pieces. All right, let's try it. Okay, let's try 500 pieces. Found 12 sets with 500 pieces. I think that's right. I think there's only just a couple little sets in this database. So let's try this again, and let's do 1,000 pieces. Found eight sets. Let's do it with 2,000 pieces. 5 sets. And let's do it with 3,000 pieces. 3 sets. So we got 5,471 pieces, 3,152 pieces, and 4,016 pieces. So it looks like it's working, right? I think we can double check the exact number by typing 352, and you see that the 352 piece set shows up. So that guarantees that are equal greater than is working versus just greater. That would be a common bug. You might just say greater, and then if you want that many pieces, you got to use greater than equal. If you want more than that many pieces, you would use greater than, of course. Okay, so we can go on and on. We could, you could add some functions to add sets to the database, to remove sets from the database. In CS260, you learn how to write sort functions, and then you could sort the data. And you could sort the data by number of pieces, by set release, by name, by product ID. We can add another field to the struct, which is the theme, and you can see a bunch of Star Wars sets versus Lord of the Rings sets versus other sets. The sky's the limit to what we can do here. Adding and deleting, and then of course we could write a new CSV file out to a file to save the file. Those are the things like that we could do here if we wanted to turn this into a big project. As you think about programs that you need to write to practice, open-ended assignments that I ask you to do, you could take my code and you could start doing stuff to it, right? If you want to add some fields and the ability to add and remove sets and things like that, perfectly okay, right? And so that's what this code is here for. So let's quit, and we are going to copy into the public folder this code here. So now you have this. And like I said at the beginning, chapter 14 maybe I didn't say this. Chapter 14 has some pretty complicated examples that I would say rival what I just did. There is this multiple file example, which is cool. Here's reading data separated by semicolons. I think the method is different. I think, yeah, in this case, using the ignore, right? And using the redirect in, the equivalent to CN, and using ignore. So you can compare that to how I did it and decide which one you like better. Um, and let's see what else is in here. Um, if your database is already sorted, how do you find the right location to insert? That's a cool thing to do, and so on. So this should set you up to complete chapters 13 and chapter 14. Um, if there's additional information you want, let me know, and we'll have another session. But hopefully this will do the trick. As always, feedback, let me know. We'll talk later.